Alright. Let's see. Everybody's here. Aha! Okay, cool. I'm ready to display. And I should be able to say test. And it should... Yep, there we go. Cool. So that does work. That's awesome. So... Cool. That's gonna be bright as fuck, but whatever. So I think I just do that. Yeah. And that just goes like that. Yeah, I don't like how fucking bright that is, but you know, it is what it is. It's whatever. I'm just gonna deal with it because I don't have the spins to actually do it. Why is this stream not streaming? There we go. Cool. So I got that. And I should be able to say yep. Cool. Alright, cool. Now back to what we were doing. Here we could say, you know, console. I just like console. I mean, I just like KDE. KDE is just, I just like it, right? I like the parameters that it can do, so. Yeah. So yeah, a little bit of a power blow. So this should be all that we need. And the reason being is that because the state machine, like these are the only things you do, and you don't really touch the state machine. You do have, I mean, you can populate the state machine with different properties and stuff, right? You could have things like the player being, you know, a global thing, or have a higher level of visibility. You could have, you know, all kinds of other stuff. But the main thing is that you have an exit and an enter, right? You have exit and enter. They are in charge of doing, you know, an exit and enter. You have the automated update, and then you have the self-dot process. machine update. I mean, we could change the names of these as well. For instance, we could just make, you know, this be update and then this be process, right? And then we change it down here to be process. And then here we have update, right? That way it's a little bit easier to do, right? Or we could even say underscore update. Right? That's probably a little bit more pragmatic. Right? Because this is the thing that the underscore update is what you don't really see, right? You don't really touch it. It's a right. It's a right. It is a right once and then done kind of situation. Right? Don't really deal with that very much. That's it all. Like ever. Right? It's not very good to have that. So that's the kind of thing that we have. Now, so all this is well and good, but we're also not really doing. Right? We have this thing, but we're not doing anything. So what if we do something a little bit different? Because what we can have is we can have the. Because what we're doing is we want to, you have the conditional, we have the update, and we do have draw here, right? Because the state machine is going to be dealing with draw and things like that. There may be other conditional things that we want to do. For instance, we want to have a draw command that the state machine ends up dealing with, right? Because there could be other things that are dealing with draw, and like the state machine itself needs to draw, right? So, because we dispatch the way that state machines work is that. The way to think about state machines is that the state machine is in charge of doing it. Right? The state machine itself is the thing that you interface with. Right? It is the thing that you use to do the stuff that you want to do. And what I mean by that is that the states that are loaded into the state machine are just the things that allow that to happen. So you want to pass everything to the state machine, and you want to have the state machine handle everything for you. So the state machine, since we're doing this in Love, so we have an explicit render function here. We have an explicit draw. We want to have a the state handles variable data and variable behavior. That's what the state does. So what we want is Sorry. Sorry. I'm just thinking about things I shouldn't. So, because with the state, we have the machine, we have the hedge. Right. Okay. So the state handles all the variable shit. State machines only have current. And in its own draw, yeah, it needs to have a draw. It needs to have a function state machine draw, and in here it is self.current draw end. Right? That's all that does. And then in state, we don't care. Right. Well, I mean, we are kind of doing this really poorly because the update, because in all actuality, we want to have this, right? And then if self update, then self.update dt, right? And what? Hold up. Because there was a way, if self update then self.update, right? I think it's self.update then self-update then self. There we go. That's the way. Okay. Cool. If self-update, then self.update. If self.update, then self-update. Then update self. Okay? If self.update, then self-update. And here as well, if self-current draw. If self.current draw, then self-current draw, and current. Right. If self.current draw, then self-current draw, and self.current draw. And literally what that's saying is that if this thing exists, then do the thing. This just keeps you from... This just kind of keeps you from calling functions that don't exist. That way, if you want to have something that doesn't have like a draw call or anything like that, you know, this is just a way to make sure that you're actually doing valid operations, right? Because Lua just goes, I mean, if you want to, right? Because you can do, like in Lua, you can have, you know, a equals 0, a, right? Like it's more mad about the fact that this is lowercase than anything else. Right? This is... I mean, it's gonna throw an error. You know it's gonna throw an error. But, like, that's how Lua works, right? You can do that. and then it'll just throw an error, right? There's no, it doesn't understand, you know, it just accepts whatever the hell it is you get to. So you do have to be careful. I mean, just like the thing about Lua is that instead of, you know, causing a memory leak or, you know, overwriting sys32, it just throws an error instead of like crashing the whole damn system. That's the difference between Lua and C++. Is that Lua is safe because it's garbage collection. It has a garbage collector. It has all these other systems in place that, you know, tracks your variables properly, everything like that. Whereas C++ does not. So Lua is C++ but Python, right? And right, so yeah, that's one of the reasons why I like Lua. That's one of the reasons why I like C++. That's why I like these languages, is because it allows you to do shit, right? It doesn't get in your way. I don't like my language to be fighting me at every goddamn step. Because I actually know what the hell it is that I'm doing, right? So we have if self that update, then self update. Good. Same thing, right? So we do overload update and we overload drop for the states, right? The main thing that we want to do okay, so we're doing new set metatable object. Yeah, function animal, right? Yeah, haha, da 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 da. Right? Is equal to O or, right? So, if you don't have the full thing, so, okay. So, with the previous prototype example of the animal prototype. Jesus fuck Christ. I don't want to be able to type. Shit. Give partial objects in the constructor, as in only give the species or sound, not both. So, okay, falls back to the prototype. Gotcha. Yeah, falls back to the prototype. Cool. Alright, so, what it does, yeah, okay. So, it has the fallback. And this is really, really powerful because then you can do a lot of really good shit, right? That means that with the edges, because you could do, because we can make I can make another one with edge, right? We can have an edge type of edge, right? Which would be the smarter way of doing things. It's more robust, it's safer. It makes sure that things are, handled properly. But I do need to use the bathroom, get some more coffee or tea or something. I need a beverage, and I need to use the restroom. So I will be right back. Alright. Okay. So good. I could make do I want to have the edges? Right? Because I can make machine be a thing, right? I can make edges be a thing. Because I want so edges being a strict type is pretty handy. Alright, because I could do an edge. God fucking damn it. Alright, because I can do edge is equal to this stuff. Because what I want to do here is have alright. So edge is going to have a condition. And this is just going to be a default, right? It'll be a function that takes in a context, or a machine, and then it returns if the machine not equals, and the edge.next, right? And then next is equal to. There we go. Alright, cool. And that's super simple, it's super easy. We just have those two things so that, things happen. And, basically, self.current update. Right? If self.current, then self.current update. That's something that we really need to do. I mean, we also want to if self-current, I mean, there's a lot of problems that we can do error correction in, like, here we want if self.current then and and then if self.current then and current. So we have these and then here we also have the if self.current then and because like we want these things to, like, if it doesn't exist, then we just don't do shit, right? And all these are just checks and balances so that we can make sure that it's robust, right? This is all error checking. And a lot of this stuff is error checking too, right? These are all things that come from working with C++. Welcome to enterprise coding, right? And this is the same kind of shit that you see in a lot of enterprise code. Is like, well, I mean, it could, it might be a thing. If it's not a thing, then don't do stuff. Right? So, I'm gonna be right back. I have a lot of stuff I'm gonna get some more water for. Yeah, I mean, and you do actually see that kind of stuff a lot in the enterprise level code. Yeah, I scorched my mouth a little bit, my tongue. So, I mean, and again, like, for the case of learning how, for the case of learning how state machines work, this is kind of a really bad example because there's like a lot of error correction, right? You know, there's a massive amount of error correction in here that, you know, are things that, you know, kind of suck, right? But, like, it is what it is and stuff. I do need to look into how, you know, delegate key delegates to state machine, right? Set meta table to, that's not what I wanted, thank you. State to edge, oh no, that's state. This is to edge, right? Right. So we have all these. We have the edge, we have the state machine, we have the state machine, edge. We have all these things, and like Vim and NeoVim, they operate on a state machine, right? Like fundamentally, they operate on a state machine. You change it's a modal system, right? Things do different things depending on what state you are currently in, right? And all that is just handled by the state itself. So that you don't have all these, like, it is, like, state machines are flow control. They are, you know, conditional flow control in a way that doesn't use a massive number of if statements. The only if statements that we're doing are going to be, you know, here, like this is an if statement, but it doesn't read like an if statement. A lot of this is just error correction. A lot of these if statements are just error correction, or just error catching, you know. Don't draw if you don't have draw, right? A lot of like no chit Sherlock stuff, you know, this self-evident instructions, right? So, like that's just a lot of stuff is like error catching, assert, you know, don't run a function if it's not a function, right? That kind of thing. You know, don't run a function if it doesn't exist, kind of shit, right? You know, and things along those lines, right? Because we want there to be, you know, just these kinds of basic bitch, you know, and all the other stuff, right? So the edge is going to be that, right? We just say return if machine not equals nil, and we can do stuff like that, right? So we have these, as our, so we have these as our conditional systems because we have an edge, we have a state, and we have a state machine. This is still, like, this is what, 60 lines of code? Yeah, this is 60 lines of code, and like a sixth of that, like 10 of those lines is error catching, right? So we have 60 lines here, and it's all, you know, fine. Like it's fine. Right? It works just fine. Now, let's go into an actual system, right? So here, what we can do is we can have a we can have like a T machine, you know, local T machine is equal to state machine or dot new or new, right? And then this is like what is this gonna be, right? Because I don't think the state machine really needs a whole hell of a lot, right? Well, I mean, we do want to have states. Okay. We could do, let's start with the state of, you know, state 1, state 2. Right? Local, you know, state 1 is equal to state new. What do we want? We want, because we need to have an enter, update, exit. Right. Well, actually, let's do this properly. Let's do this shit properly. Right. Let's do a function state enter and function state update dt and then a function state draw and then a function state exit and right. So we have all these. So we have enter, update, draw, exit, exit, and then the update, right? We have all these. Like all these are like super smashed together. There's a lot of ways that why this is fucking dog shit, but it doesn't really matter to me. I'm not too terribly worried about it. There are some things that I want to do because I want to have like state new, and then like state 1 is new, and then I can say that the machine is, because I want to have, I mean, the state machine is going to be doing stuff. I also feel like I need to end stream for a little bit. I really need to go to the bathroom for a bit. Yeah, that's not what I want. Thanks. Yeah, I will be back.